Yesterday's video was pretty long. This one will be pretty quick. So we're going to keep working with multiplying decimals by decimals, but we're going to work on word problems today. So I'm going to have you turn to page 204 again, which is the guided practice that we were working on yesterday. And we're going to work on problem number 7. So problem number 7, still multiplying decimals by decimals. We're just working with word problems now. A mile is equal to approximately 1.609 kilometers. How many kilometers is 2.5 miles? So if 1 mile equals 1.609 kilometers, we need to figure out how many kilometers 2.5 miles is. So that means we would multiply those two numbers together. So I'm going to write the number with the greater amount of digits up on top. And then 2.5 is going to go underneath, but it's going to line up with the digits, not the decimal points. Multiply as is if we were ignoring the decimal points. 5 times 9 is 45. 5 times 0 is 0. Plus 4 is 4. 5 times 6 is 30. 5 times 1 is 5. Plus 3 is 8. Bring down my 0 to hold my spot. 2 times 9 is 18. 2 times 0 is 0, plus 1 is 1. 2 times 6 is 12. 2 times 1 is 2, plus 1 is 3. So then we're going to add straight down. 5 times 0, or 5 plus 0 is 5. 4 plus 8 is 12. 0 plus 1 is 1, plus 1 is 2. 8 plus 2 is 10, and 1 plus 3 is 4. So now I need to go back and count how many digits are behind a decimal point in the original two factors. I have 1, 2, 3, 4. So 4 is my little number I'm writing over here. My decimal point starts on the right-hand side of my product, and then I move it 4 places to the left. My answer becomes 4.0225. And then just like with every other word problem, we need a label. So how many kilometers is 2.5 miles? So we can write kilometers. We can shorten it as our label. Now let's just double check, go back and see if that makes sense. So I have roughly around, we're going to round 1.609. I would round that to 2. That's pretty close to 2. Then we have 2.5. You could round that to 2 or 3 depending. So if we rounded each of these to 2, 2 times 2 should give us around 4. If you rounded this to 2 and this to 3, 2 times 3 is 6. This is still pretty close to 6, even though 4 and 6 kind of seem like farther away from each other than what they really are in this case. But we are just checking to make sure that our decimal point is in the right spot. If we were to get 40 or 0.4, we would probably have a red flag thrown saying, yeah, something's not right. Okay, so 4.0225 is our answer for that one. Let's flip over to the next page. And let's do problem number 7 on the next page as well. So problem number 7 says, a giraffe can run up to 46.93 feet per second. How far could a giraffe run? In 1.8 seconds. 46.93 feet per 1 second, but if we're running in 1.8 seconds, how many feet does the giraffe actually run? So we're going to multiply 46.93 times 1.8. Remember, we line up the last digits in the number, ignore decimal point, and we multiply as is. Okay, so we get 8 times 3 is 24. 8 times 9 is 72, plus 2 is 74. 8 times 6 is 48. 48 plus 7 is 55. 8 times 4 is 32. 32 plus 5 is 37. Okay, we bring down a 0 to hold my spot. 1 times 3 is 3. 1 times 9 is 9. 1 times 6 is 6. 1 times 4 is 4. Now we get to add straight down. So we have 4 plus 0 is 4. 4 plus 3 is 7. 5 plus 9 is 14. 7 plus 6 is 13, plus 1 is 14. Now let's do 3 plus 4 is 7, plus 1 is 8. Okay, 8, 4, 4, 7, 4. Let's go back to the original problem in the product or the factors and count the number of digits behind a decimal point. I see 3. So that means I'm going to start on the right-hand side. I'm going to move it 3 places to the left, and I now get 84.474 as my digit or my numerical answer. Now I need a label. So it says, how far could a giraffe run in 1.8 seconds? Well, far is what we're looking for. And then you have to look back for the measurement for distance, and that's feet. So our answer would be 84.474 feet. Okay? All right, so I did 2 problems for you there.